I want to start with the breaking news out of Iceland. As you can see from these dramatic pictures there.
A volcano is erupting in Iceland, spewing ash and lava into
A volcano has erupted
Now to Iceland, where a volcano has erupted.
We have been hearing the news of Icelandic volcanoes since some time now. The amount of these eruptions have increased a lot more since 2021, and not just this, the amount of lava oozing out has also 10x'd since the previous eruptions. There is so much lava coming out that it can be seen by the European Space Agency's Sentinel-2 satellite. But why is this actually happening? See, there are two major reasons of the same. The first reason is the geographical settings, and the second reason is the rapid expansion of fissure. Don't worry, let me explain it to you. We all know about tectonic plates, right? That float on the Earth's mantle and are in constant motion due to the convection of the Earth's current. Two such tectonic plates, the North American plate and the Eurasian plate, seem to be diverging, which means that these plates tend to move apart from each other. Now, the fun part is that this diversion is under ice-cold water, and interactions between hot magma and ice-cold water leads to explosive eruptions. This diversion boundary is known as the Mid-Atlantic Ridge, and Iceland is located just above this ridge. Lava follows the path of least resistance, which means that it follows the path of gravity, and anything that comes in its path is essentially buried. I was recently hearing a scientist say that when she was walking near to a lava flow, she got full sunburn. Freezing lava could also be a solution, but it is not practical because it requires a lot of cold sea water. And essentially, the problem is not the lava. The problem is the people living around them. According to a report I saw, there are about 1 billion people which live in the vicinity, like approximately 100 kilometers of such active volcanoes. So this comes out to be a big problem. But I guess there is a hopeful side to this too. This disaster can be a source of the cleanest form of energy, the energy which is powerful enough to supply electricity to about 25% of the country and to supply heat to about 90% of the houses of the country. I am talking about geothermal energy. Geothermal energy is the energy of Earth in the form of heat that can be used and harnessed in the form of electricity. Hot water near the core of Earth generates steam, which rotates the turbines and activates the generator to produce electricity. And the water is pumped back to the cooling tower and then back to the reservoir. This is how a basic geothermal plant works. Now imagine how hot is the temperature of lava. If by any chance we are able to drill directly into the magma chamber, imagine how much energy we can harness from the same. To be honest, I'm not the first one to think about this. In 2009, an Icelandic deep drilling project drilled 2100 meters down directly into the magma chamber. And this was really unexpected for the very first time in Hawaii. And what happened was that the volcano did not erupt, but the drill seemed to be destroyed. This led to the starting of KMT, Krafla Magma Test Pit. KMT is an organization that aims to drill directly into the magma chamber for the very first time in 2026. According to a research paper, magma turns out to be 10 times hotter than a rock because of the latent heat of crystallization it has in it. It also tells that if thermal fracturing is done on the rocks just above the magma chamber or at the lid of the magma chamber, geothermal energy can be extracted with approximately 3% more efficiency. And to be honest, if we are able to do the same, we can harness geothermal energy without going deep into the rocks. And we can harness a lot of geothermal energy from these volcanoes, and this disaster could turn out to be a big boon. But let me tell you, this is not that easy. Creating an equipment that can handle such harsh temperatures is a difficult task. Also, there would be a need of new sensors that could measure the temperatures just below the magma chamber so that the drilling could be done effectively. Even if we are able to drill into the magma chamber, one of the most challenging things would be handling those ultra-hot fluids. But on an optimistic note, keeping all these challenges aside, I am really excited to see what KMT does in 2026. If you have any additional information, do let me know in the comments, and also let me know that what do you feel about the same. Thanks for watching. We'll meet you in the next video with another optimistic science and tech story. Till then, bye-bye.